Welcome to all. Okay. Now, question number 48. See, what I am doing is, I am going for covering all load combinations for cantilever. Now, uniformly varying load starts. With the only uniformly varying load we had done earlier. Now, with the combination of loads. Once these combinations are over, I will start giving simple questions for you to solve. Very, very simple. Those will be question with direct answer. Okay. Start. Question is here. If you want by words, a cantilever beam is of length 3.2 meter. It is fixed at the left end, understood, free at the right end then. It is loaded by uniformly varying load of intensity 0 at left end and maximum of 60 kN per meter at right end. Or you can tell 0 at fixed end and maximum at free end. 2 point loads 80 and 60 at 1.7 from fixed end, left end, and 0.6 from right end or free end. And an anti-clockwise couple of 100 kN meter at the right end, that is free end. Find support reactions. Okay. Let VA upwards, MA anti-clockwise as usual. Usual statement you write. Okay, then start. First, before that you have to mark the reaction. See, we are assuming VA upward. This all I explained earlier. If any confusion is there, take this way. Later you can make out. Okay, take moment about A. See, moment about A, be careful. Finger should be at A. Okay, I can't lift the hand. Minus 100, no distance. Plus 80 into 1.7, see there. 60 into, see, this is 0.6, this is 3.2, this is 2.6. Or from 3.2, subtract 1.7, subtract 0.6, you get 0.9. So 60 into 1.7 plus 0.9, that is 2.6. Then total uniformly varying load, see. The total load will be acting somewhere here, I don't know exact version. Half into base 3.2 into 60. This 60 is not this 60. This is point load 60, it's intensity 60. Half into 3.2 into 60 is the total load into, from here, 2/3 of 3.2 minus MA equal to 0. You get the value of MA positive. Sigma V0, waste of time explaining. Plus VA minus 80 minus 60 minus total UVL half into 3.2 into 60. This is not there. Equal to 0, you get VA, then go back, not go back, therefore write this sketch once again there, right, final reactions are, both came positive, means what direction you assumed is correct, 236 kilonewton, and reacting moment MA, anti-clockwise. Why anti-clockwise? Because we assumed anti-clockwise, it came positive, 396.8. kilonewton meter. Question number 48 over. Question number 49. I will prepare and explain to save the time. Question number 49. Words become too lengthy, so I will give sketch directly. Find the reactions for the beam shown. As usual, statement I have not changed here. So take moment about AC. 1 plus 0.5 plus 1.8, all these three, subtract from 4.2, what you get? You get this UD loaded length. See, this 0.9, you can calculate that one. Total length I forgot right here. Total length is 4.2 meter. Okay, now very simple. Take moment about A. Finger here. See. Start from order. Plus half into 1.8 into 6 is the total load. It will act somewhere here. See, here it will act. Into 1 plus 0.9, 1.9 plus 0.5 is 2.4 plus another 1/3 of 1.8 plus 30 into 1.9 plus 20 into 1 plus 24 into 0.9 is the total load into 1 plus 0.9 by 2 minus MA equal to 0. MA will come 124.52 positive. Sigma V0 plus VA minus 20 minus 30 minus 24 into 0.9 total load minus half into 1.8 into 6 is 0. You get the value of VA. Therefore, support reactions are, put the sketch once again, mark reaction VA equal to 77 kilonewton and reacting moment MA equal to 124.52. The space is not there. I'll put here MA 124.52 kilonewton meter. So I consider uniformly varying load represented by right angle triangle, one's full span. Just now on the right side I consider. Next, somewhere in between I will consider one by one case. Next question, that is question number 50, I'll change the loading. These are all for thorough. The purpose of all this is to completely get the grip on the subject. Next question 50, for the beam shown in figure, no words, find reactions. Now right side is fixed, be careful. So VB we will take upwards, this will create anti-clockwise, so we will take clockwise, all explained for you. VB upwards and VMB, now this time we will take clockwise because we know it's clockwise. Okay. Clockwise, B at B. Put the neat sketch here, everything is clear. Take moment about B. Stand here. Minus 80, no distance, minus this load, somewhere here. Total load is acting here. Minus half into 2.4 into 40 is the total load into, see all written here, 1.6 plus 2 by 3 of 2.4 minus 50 into 1.6 minus 20 into 1.6 into 1.6 by 2 plus MB0. You get the value of MB. Sigma V0 plus VB minus couple is not there, half into 2.4 into 40 minus 50 minus 20 into 1.60. See, these all I am not explaining because in the type of loads I explained it, you can tell infinite times. So those people who cannot understand, who cannot go through all this and simply want to come to today's class, this class is of no use. Sometime I have seen people solve one question, they will take half an hour for this question. That's all. That's over, cantilever over. Instead of that way, first teach systematic basic concept, then go for calculation. Okay, right. Therefore, as usual, final answer, your reaction VB upward equal to 130 kilonewton, no plus minus, moment, reacting moment MB equal to 339.2. See, sometimes when I looked first, it looked like 337.2 for me. I checked once again, it came 339.2. So that calculator mistake, once the steps are clear, you check the answer. Okay, now 51. Okay, now I will go for some other loading. I will solve in front of you only. Some new type of question, something special will be there. See, there will be something special. Otherwise, I won't waste time for unnecessary same thing again and again. You see, to save the time, don't bother. 51. See, I will give the beam here, question. Once again, fix that side. Now, see. Full span this way already told earlier, 20 kilonewton per meter. See, this loaded length is, see, 2.4 meter. And it is told in the question that midpoint is at 1 point. See, not midpoint, the maximum at center. Okay, now, this distance required, this distance required. This is 1.2. 0.8 meter, this is 0.9 meter, okay. One clockwise couple here of 85 kilonewton meter. And then to understand correctly one UDL here. UDL of 40 kN per meter. Here, 1 point load, 60 kilonewton. Okay. AB, what you are covering is uniformly varying load represented by a isosceles triangle, not full span. Full span already over earlier. Okay, start. Let VBMB same statement. Then put a neat sketch. I have to solve this in front of you now. I will solve, no problem. Again, when I solve, if the calculation mistake is there, you manage it. 0.9, 1.2, 1.2, and 0.8. Little bigger. Okay. 1.2, 1.2, 0.8. Okay. Important is what? Uniformly varying load represented by an isosceles triangle. This is 20 kN per meter, along with other combination of loads. 1 point load 60 kilonewton here, 1 UDL here, 40 kN per meter, 1 clockwise, see this couple is clockwise now, 85 kilonewton meter. Lengthwise 0.9 meter, this is 1.5 meter, 1.2 meter, okay, 1.2 meter, this is also 1.2 meter. So actually the total 2.4 is not required. We will calculate now. It is not required in the question. 2.4 meter. And this is 0.8 meter. A and B. Okay, see. Downward loading, we will assume upward reaction VB. All these loads will create anti-clockwise, but one clockwise is there, but we are sure that this is predominant. So if this is predominant, this is the balancing moment, MB. Okay, we will see later. In case it is wrong, negative sign will come. Okay, take moment about B. Plus 85, no distance, minus C. This total load will act here. Now see, this load, total load, because symmetry is there, it will act here. So minus plus 85 minus 40 into, no into there, 0.9 is the total load multiplied by from here, 0.8 plus 1.2, 2 plus 1.2, or 0.8 plus 2.4, 3.2 plus half of 0.9, 3.2 plus 0.9 by 2, this is also over, minus, see, this is full UVL, half into 2.4 into 20 is the total load directly. This is total load into, see, represented by isosceles triangle, resultant will come here, 0.8 plus 1.2. Why 1.2? Half of 2.4. Then minus 60 into 0.8. Lastly, plus MB equal to 0, you get the value of MB. Sigma V0, upward positive, VB minus 40 into 0.9 is the total load for UDL, minus half into the total loaded length is 2.4 into 20 is that load, total load, minus 60 equal to 0, you get the value of VB. I will calculate both. Actually, I can leave without answer also, but I will calculate. If by chance calculation is wrong, correct it. I won't waste time, T4 time calculation, 85. See, when I give the steps here, answer does not matter. When I give direct answer, then the answer is compulsory, because why? If you don't get the answer, that means you have made some mistake. 85 minus 40 into 0.9 into 3.2 plus 0.9 divided by 2 minus half into 2.4 into 20 into 0.8 plus 1.2 equal to minus 60 into 0.8. 142.4 plus 142.4 kilonewton meter. 20 into 0.4 is Okay, maybe correct. Okay, sigma V0 0.9 plus half into 2.4 into 20 plus 60 is 120. I'll check the moment once again. One minute. I won't see the answer here. 85 minus 40 into 0.9 into 3.2 plus 0.45 minus half into 2.4 into 20 into 2 equal to minus 60 into 0.8. 142.4, correct. Therefore, after everything is over, right, support reactions are as shown below. This vertical reaction is VB equal to 120 kilonewton. This reacting moment MB equal to 120, not 120, 142.4, sometime wrong reading, 142.4 kilonewton meter. Okay, over. Now question number, one more last question today, 52. What I will do is this triangle, I will change it over to general triangle so that you have little difficulty, not difficulty, little concept required. Okay, no problem. But I will make fixed and left side now. I will keep on changing it. Sometime left side, sometime right side. No, that is not a problem. Okay, question. See, only that, 1 minute, I will put the load first. The question is here, 52. Oh, okay, this way. Only this much load, already over earlier. Usually I show double line for cantilever, habit, 60 kN per meter. See, this total length of load is given, 1.2 plus 2, 1.2 plus 2.1, 3.3 meter. 3.3 meter, then they told this cut distance is given 1.2 meter. Okay, over. Then, okay, one point load is not required, but I want some loading. Okay, one UDL here. One UDL here, but remember, UDL of this is 1.2, this distance is 1.2 means 0.9 meter. The UDL is from 40 kN per meter, but it has got a gap here of 0.2 meter given in the question. Here, 1 point load, 25 kilonewton. Here one couple, anti-clockwise couple of 50 kilonewton meter. Okay, sufficient. Our important is this load. Over. So let 6 and A, this is P. Let VA upwards, MA anti-clockwise be reaction set fixed support at A. Now write a neat sketch. 3.2 plus 0.9 is, this distance not to be given, this distance is given in the question 0.8 meter. 0.8 meter. So let's say beam here to understand correctly. See, I use the full length to understand. A beam of total length, I write here total length, 3.3 plus 0.8 plus 0.9, 5 meter. Just check the answer. That is so important. 3.3 plus 0.9 plus 0.8, 4.9. 0.9 plus 3.3 plus 0.8, 5 meter, correct? See, calculator problem. Then 0.8 meter gap, then 3.3 meter here, 3.3 meter up to here, okay. There, 1.2 and 2.1. 1 point, okay, somewhere correctly reasonably okay now. See. Somewhat okay. This is little smaller. 1 minute. It should look reasonably, it should look correct. 1.2 here, 2.1, okay. Now okay. This is 60 kilonewton per meter. An anti-clockwise couple here of 50 kilonewton meter. A point load of 25 kilonewton. Here UDL, a small gap is there, 0.2 meter gap. See now, distance wise, this is 1.2 meter. This total length they told 3.3 meter. If that is 3.3, this will be 2.1 meter. You calculate. Then this will be 0.8 meter. This total length is 0.9 meter. No, 0.9 not required. See, there is a UDL here. See, up to here. How much UDL? 40 kilonewton. See, this all will give you more and more concept. UDL loaded length is from 0.9 subtract 0.2, 0.7 meter. So this gap will be 0.2 meter. Okay, everything will be clear. Now, this is A, this is B. Vertical reaction VA, reacting moment MA. Okay, start. Take moment about A. Sigma M about A equal to 0. Take clockwise positive. Now, this I will write last, not now. Okay, start. 25 into any couple, okay. 25 into 5 plus 25 into 5 minus 50, no distance, minus 50. I will write last here for some reason plus this UDL. 40 into 0.7 is the total load. The total load is acting here into 0.2 plus 0.7 by 2, 0.2 plus half, then this one plus. Now see, correctly make a note. You can consider the entire triangle in a single stretch. I told then the centroid will be somewhere here. If you remember, this distance will be, I told you total load is acting here. Total length 3.3 plus this cut length 1.2 divided by 3. I told L plus A by 3 here, L plus B by 3 here. If you took the entire triangle, so in that case plus half into 3.3 into 60 is the total load. See, this is a total load from, do one thing, A, B, you make it C and D to understand. Total from C and this you make E point. Total load from C to D into, from here, 0.2 plus 0.7 is 0.9 plus from here to here is 3.3 plus 1.2 divided by 3. I already explained more than 100 times minus MA equal to 0. You will get MA. First I will get MA value. Last question. I will take my own time. Not too much time. I will start from here to avoid confusion. 0.9 plus 3.3 plus 1.2 divided by 3 is 3.3 plus 1.2 divided by 3 is 1.5. Okay. I'll get 1.5 plus 0.9 into half into 3.3 into 60 is this moment over plus 40 into 0.7 into bracket 0.2 plus 0.35 minus 50 plus 25 into 5. 328 plus 328. I'll check the answer once again. Kilonewton meter. I'll check the answer once again. Saber side. I will not see answer here. I will see there only. 40 into 0.7. I don't require writing all into 0.2 plus 0.35 plus half into 3.3 into 60 into bracket 0.9 plus bracket 3.3 plus 1.2 close divided by 3 equal to minus 50 plus 25 into 5. 328, correct. 328 kilonewton meter. Okay, now do one thing. Write here. You can write here or make a note. Or those people, you make a note once again, right? Or don't think. First you finish the question. Not or. First you finish it. Sigma V0 upward positive plus VA minus 40 into 0.7. If I explain this one, people should stop seeing my class. They should tell you are wasting time. Minus half into 3.3 into 60 minus 25 equal to 0. Your VA will be 40 into 0.7 plus half into 3.3 into 60 equal to plus 25 is 152 kilonewton. 152 kilonewton. Therefore, go back here, right here. This reaction VA is 152 kilonewton. This reacting moment MA is 328. If anything is wrong, check later. 328 kilonewton meter. Okay, now make a note. One note make here. Sometimes people have difficulty of this formula. In that case, do one thing. You consider this triangle and this triangle separately. In that case, here 25 into 5 minus 50 plus 40 into 0.7 into same thing, and then see one load acting here, one more load acting here. Okay, this load first you write separately now. See. Then this load half into 1.2 into 60, that is that half into 1. That is the total load from C to E into 0.9 plus this distance is 2/3 of 1.2, this over again plus clockwise this load half into 2.1 into 60 is the next load, space is not there, into 0.9 plus 1.2 plus 2.1, why calculate it? 0.9 plus 1.2 is 2.1 into 2.1 from here to here, see 0.2 plus 0.7 plus 1.2 plus 1/3 of 2.1. 1/3 of 2.1, then lastly minus MA equal to 0. Guaranteed same MA will come. If not coming means calculation mistake. Check the calculation. Over. Enter the reaction. 52 over next 53. Next 53. That's all. Enough for this class. I'll continue in the next class. Okay, thank you.